I should have started by saying this at the beginning. Our community, for those who are new, is the most fundamental unit of our community is a work stream. What is a work stream? A work stream is 3 or more of you care deeply about a new feature or a bug or a problem that you want to solve within Mojaloop. And so you meet weekly and you assign yourself tasks and work to resolve this problem or to build a new feature that then gets built or included in future releases. We have a number of work streams. These work streams are public. If you go to our community website, that's community.mojaloop.io, somewhere in the navigation bar on the left-hand side of your screen, you will see a link written active work streams. And on that page, there's a list of all the work streams that we have running at any particular time with an incredible amount of detail. Everything from what objectives they're trying to accomplish, what tasks they're currently solving, who the workstream lead is, what documents or which page on GitHub, the issue trackers they're using, the times that they meet, and all that stuff. And I want to first of all, call out and thank all the workstream leads. If it's not too much to ask, if you are actively involved in a workstream, could you please rise so that we could thank you for your work? All the workstream leaders and people actively involved in the workstream, kindly rise. These are the people who, week after week, day after day, put in a lot of effort to make sure that we have releases, things that we are able to come here every PI to talk about and to include in our future releases. So if you bump into any one of them, you will recognize them. They have a green pin, such as the one I have here, written workstream leads. Please do thank them for their service. And also do consider participating in a workstream. The session that we're about to have is a bumper. We're going to condense a couple of workstreams, I think 6 workstreams, 4 workstreams into one. So it's a report out. For the last 3 months, these workstreams have been actively involved in a number of tasks and objectives and goals. And this session is aimed at showcasing what progress has been made, what help they require, and more importantly, this session is aimed at helping you find your space in these work streams. So please, I'd like to invite James Bush, our engineering director at the Mojaloop Foundation, to take us through this session. James.
Thank you, Simeon. Hello, everybody. Great to see so many familiar faces here. Okay, as Simeon mentions, we're going to condense report outs from 4 work streams this time. And we have some demonstrations and one presentation from one of our work stream contributors to share with you during this session. So I'm going to try to go through the slides as quickly as I possibly can to make enough time and space for those demonstrations. Okay, so participation tools. This work stream falls under our first pillar. I hope some of you may be familiar with our product pillars. We have a pillar, make adoption easier. In the early days of Mojaloop, we recognized that people in the community who wanted to build IIPSs were encountering difficulty with taking our software off the shelf, deploying it, configuring it, making it work for them to deliver their scheme functionality. So this work stream exists primarily to make sure there's a good set of tools in the open source code base that helps people join and participate in Mojaloop-based schemes. We spend a lot of time gathering and documenting requirements from the market. We speak to a lot of people who are working for DFSPs and switch operators, hub operators, system integrators who actually perform the technical task of onboarding financial institutions, banks, MFIs, SACCOs into schemes, the pain points they encounter along the way, both technical and business. And we try to focus our efforts on coordinating the work to remove those barriers, to make it easier for people to join and participate in Mojaloop schemes, both big guys and small guys. Remember, one of our guiding principles is that we want everyone to participate in the same scheme. So keeping the cost barriers and the business complexity requirements to a minimum is where we spend our time. So over the last 3 months, our objectives have been focused on a few special areas within that broad remit, primarily our connection management tool suite called Mojaloop Connection Manager, MCM for short. So Yev, who's been presenting a couple of times this week, and we'll see a demo from him in a minute. Yev has been spending all his time over the last 3 months refactoring some code in the MCM tool space to further simplify the process of onboarding DFSPs into Mojaloop schemes. We've also spent some time pulling in code that's been donated by community members. In this case, Infotex have donated the payment manager product code base to the Mojaloop Foundation for our stewardship. We're doing some work to standardize the CI and CD pipelines on that code base, bring the documentation up to our community standard before we officially support the product in the coming months. We've also been trying to simplify from the perspective of the tool user, SIs, financial institutions, and scheme operators. We want to make their job of using these tools as simple as possible. So we've been thinking about how to repackage those to make them easier to understand, to figure out which tool is going to suit your particular use case the best. Some of you who are familiar with our GitHub code base will notice that we have a very large number of repositories, somewhere in the region of 200 code repositories. We were receiving feedback from the community. It was quite hard to understand which repositories are which. So we've spent some time indexing and categorizing those repositories with the hopes of publishing an index that will help point people at the right place to look for the right piece of code to solve their particular problem. What progress have we made this PI? Well, it's been very busy, but we have successfully released a refactored MCM, which is much easier to deploy than previously. In the past, you needed to use our infrastructure as code deployment system to use the connection manager. You don't need to do that anymore. So if you're running a self-managed Kubernetes cluster, you can just use Helm to deploy the MCM toolchain. We've made significant progress on the payment manager code base as well. There's about a dozen repositories. We're through about 2/3 of those so far. That task will continue into the next PI. We have done a considerable amount of work in improving our documentation around the shrink wrapping and packaging of those solutions, so it's clearer which repositories you need to download and install in order to use these tools. With Sam, actually, who was just speaking a minute ago, Sam has done a considerable amount of work on indexing our repos and categorizing them. We're very close to publishing that now. So at this point, I'm going to give you a break from my voice for 5 minutes and show you a video, a pre-recorded demonstration that you have made a couple of days ago of the new onboarding experience for smaller financial institutions using the MCM toolchain. So if I could ask our AV team to play the video. Thank you.
Hi, everyone. Today, I'm excited to demonstrate the MCM agent, a new tool that can dramatically simplify the FSP onboarding in Mojaloop. So previously, to configure Mojaloop deployments, the FSP operators had to manually configure Docker environment variables, which could easily break deployments. So worse, they needed to have admin rights on deployments. So essentially turning them into DevOps engineers. And with MCM agent, this problem is going to be solved, and I'll show you how it works. So first, the hub operator creates a new DFSP through the MCM server interface. So I'm going to do this right now. I'm going to the hub, enter some SP1 name, SP1, SPCOM. So right now I'm using the mail hog for email address, so it doesn't matter for now. So when we click submit, MCM server will automatically provision credentials for API access. It will send email invitation and configure everything for the FSP to onboard. So if we go to the mail hog, our mail server, we can see the invitation, and we are going to log out from the FSP from hub administrator. Go to the sign in, sign up phase for the FSP. Next, we'll use the password. Fill up the password and the first name, last name. So it will be FSP1, the FSP.
Is there an issue with the video not updating the screen?
So we logged in as the FSP operator. So right now we are ready to onboard the FSP. So let me open the MCM agent. So here you can see the real-time terminal UI showing exactly what's happening during onboarding process. So no more guessing, no more checking Docker logs across multiple containers. This is the standard deployment that can be provided to the DFSP operator. It's not configured, it's just standardized. So you can see different states of the DFSP deployment on the status tab. So DFSP CA creation state, some JWS keys state, other information, and this is like real time. So each state has its own status and the information about any errors occurring during that. So switching to the next step with just arrow keys, we can see the configuration that right now exists for the DFSP. So everything in one place. Switching to the edit tab, here we can see the user-friendly interface for modifying different module loop SDK parameters. So you can modify currency, update endpoints, set wealth settings, and so on. So you can use your arrow keys to select what you would like to set. So we are going to deploy this DFSP right now into the hub, just using this interface. So we've just registered as the FSP1. So I'm going to set FSP1 here. Then I'm going to set it to the MCM server, which is MCM API demo local. MCM API. Then we can set the MCM client ID, and we can get this one from this integration tab, the recent addition to the MCM server. And yeah, so we can generate the credentials so it can be used by the FSP. So let's do it. Can set the client ID, then the client secrets. So all this information is stored securely in vaults, all these configurations. So you don't need to be worried about security of this data. So I'm going to use MCM eclock demo local. Then I can leave this one as is. Yep. So we are ready to go. I can push save. Integration is saved. And now you see most of the states are completed. Just this one has some error, meaning it needs the CA. So if we go to the actions, and here you can see a list of actions a DFSP operator can perform, like create internal CA or upload some external CA, create client CSR, regenerate server certificates or JWS keys. So we are going to create a DFSP CA right now. We will just use some defaults, click submit, and that's all. So right now, you can see most of the states are done. And now we are just waiting for a hub operator to sign our client certificate. So we go to the back to our MCM server, and we are going to log into our hub operator account. So go to the client certificates. Here we can see our CSR. So we're going to just sign it. And in a moment, the status should update. So everything is done in real time. So the FSP operator will not lose the scope of what's happening. As soon as this configuration is completed, all these configs in real time are pushed to the SDK scheme adapter. So you can see everything is completed. And at this point, basically the scheme adapter is fully configured with the TLS certificates for secure communication, JWS keys for messaging and signing, hub endpoints, auth keys, and the FSP can now send and receive payments, and all done through the user interface. So no DevOps knowledge required. Also, for convenience, the FSP operator can use a web UI. So if this UI is for day one configuration, the web UI can be used for day two. So here is how it looks like. You can see the system status page with all the statuses here. Then the configuration can set basically the same information, maybe in a more convenient way on the UI. Can enable or disable authentication. Then you can set some things like here, like accept payments, accept quotes, whether or not to validate JWS keys, and do mutual TLS. So, and the same goes for the actions. We can do certificates creation, JWS keys creation. So we can, for example, try to recreate certificates from here, and it's going to be recreated. So we can see from actually even make some regeneration from here. And like this, we just regenerated our CA. So yeah, this is the new approach that can significantly ease the onboarding of the FSPs and at the same time provide better observability of the status of the DFSP onboarding. Thank you.
Okay, thank you. So some of you may recognize some elements from that user interface as being quite similar to the payment manager product. So I just want to mention that what you've just seen can be run by the very smallest DFSP, a very small MFI or SACO who has maybe a server under their desk or a couple of servers in a shared data center. Somebody without much internal technical capacity can follow the secure onboarding process to join a Mojaloop-based IOPS with very few steps and achieve the same level of security, durability, reliability, and resilience as the big guys. So, if anybody in the audience would like to join this workstream, we are always looking for contributors. It doesn't matter whether you're an engineer, programmer, a product person, a business person. We're always interested in hearing your views on how to remove barriers for participation in IOPS schemes. So please come and join us. All these slides are shared after the event, and my apologies for the quality of the video reproduction there. We will share the original video, which I promise doesn't have the lag that you just saw. So you might have a clearer view of that process. Okay, deployment tools workstream. Deployment tools, like the name suggests, is focused on making it easy to deploy Mojaloop. The core software platform is event-driven microservices. There's lots of microservices. There's lots of Docker containers, lots of code artifacts that need deploying into a server farm to make a working Mojaloop switch. The job of this workstream is to make that process as smooth, reliable, reproducible, and easy as possible. We set ourselves some objectives for this previous PI. We wanted to improve our documentation around our infrastructure as code. Significant amount of effort has gone into that. We wanted to update our feature matrix. So in our documentation, we specify the 3 or 4 different ways you can deploy Mojaloop based on your particular use case. If you want to understand Mojaloop, if you want to help develop Mojaloop, if you want to test Mojaloop, if you want to build a real scheme on Mojaloop. There are different options, different ways for deploying Mojaloop software. And we have a feature matrix published on our documentation website which guides you towards the right repositories, the right tools to use to make that happen. We've been enhancing that documentation over the last 3 months. We spent some time working on our Helm charts as well. I hope some of the engineers in the room will be familiar with Helm. For those who aren't, it's our way of packaging the Mojaloop software together, all the components in one package. We've been improving that packaging to include some of the supporting services that exist around the edge of the core. So now optionally you can deploy those into a self-managed Kubernetes cluster in a much more user-friendly way. So far, those improvements include the ability to deploy the finance portal, our monitoring stack, MCM, the server-side components of what you just saw demonstrated in the video. Those can all now be deployed via Helm charts. We have a problem, not a particularly difficult problem, but it's always hard in a complex software project to make sure your documentation is up to date. So in all of the work streams that I'm involved in, at least, we spend a considerable amount of time making sure our documentation is complete and updated. So we've spent a fair amount of time over the last 3 months making sure any of those documents that we had that may be lagging a version behind have been updated. But also in the work stream, we keep a list of missing features, things that people have asked us for that the current software platform doesn't provide. So we also keep a checklist of those things that we feed into our agile delivery process for our work streams. So we know what we need to prioritize work on in the coming weeks and months. During the previous PI, there was a release of IAC made, which had a lot of new features to support the DRPP project. Many of you will have seen the presentations on that this week. A very, very large project with lots of moduloop switch instances all working together. Well, the IAC was significantly enhanced to support that deployment, but it resulted in an increase in the base level cost footprint for deploying the basic moduloop switch. So we immediately recognized that this was suboptimal, and we set ourselves the task of fixing this. Progress we've made. Well, given that we're still working on that issue of the baseline cost of the IAC deployment, we've paused work on the documentation for now. But we have updated the feature matrix. So the latest version is now live and published on docs.moduloop.io. So if you need to find out what your options are for deploying Moduloop, you have a nice updated, easy to follow guide. The Helm charts, we want to continue working on the Helm charts. We've made significant progress, but it's an ongoing objective for the work stream. I don't think it's likely to ever come to an end. As long as we're adding new components, new features, and making changes, those Helm charts are going to need ongoing maintenance. So as I mentioned, we had this issue with cost footprint. So one of the mitigations that we thought was most appropriate after extensive discussion within the work stream and within the other product management functions in the community, we decided to start work on a light version of IAC that has all the production quality niceness of the full fat IAC, but with a much lower cost footprint. So it has the same security, reliability, redundancy, etc. But some of the larger, more complex and costly to operate features to support cross-border FX, multi-region schemes don't exist in this version. So the ultimate result is a lower cost footprint. So work has begun on that. We've made some reasonably good progress. We're initially targeting deployments on bare metal on-premise using the Proxmox virtualization layer and a Kubernetes-focused Linux distribution called Talos. But we're also targeting AWS and GCP. We're always in need of resource on this work stream. We have Terraform coding happening at the moment. We could always use some help with DevOps and deployment tooling and coding. So if you're interested in getting involved in anything to do with the deployment process of Moduloop, if you want to share your views on what would make your life easier as a deployer, then please come along and join us. You can easily catch up on what's been happening in detail in these work streams, in this slide deck, I've shared links to the working notes documents. We keep detailed minutes of every weekly call we have. Please reach out on Slack. Okay, how are we doing for time? Performance work stream. Okay, this falls under our quality product pillar. This is another long-running work stream. It's the way we continuously keep an eye on the overall performance of the Moduloop code base as features are added and bugs are fixed. The usual daily update process for the many dependencies that we have goes on. These things very often make an impact on the overall performance of the switch, the throughput and the latency of processing transactions. So we keep an eye on that by running performance tests. So our overall long-running objective is to make sure we continuously understand the factors that affect the performance of the Moduloop switch, so we can make sure we're delivering the most efficient software we can. This PI and previous PI, we've been working towards producing a white paper to describe a model that will allow adopters to calculate, figure out how much infrastructure and of what type of infrastructure they will need to achieve a certain level of performance, certain number of transfers per second, and transfer processing latency through the system. That white paper is well underway. We're still gathering data and processing that data. But so far, in the last PI, we have executed scaling points at 100, 200, 500, and just recently 1,000 transfers per second in our AWS test environment on a minimal hardware footprint. We have a comprehensive test plan which covers several hundred test scenarios. Most of these test scenarios require running up to 1 million transfers through the system for a continuous long period of soak testing at very high throughputs. So that 1,000 TPS benchmark that we achieved in the last few days was running flat out 1,000 TPS for 1 million transfers. Yeah, thanks. And so the core switch components that we achieved that on were just 3 AWS nodes. So the performance optimizations that have been happening, Sam mentioned the work that's been happening there as well in his talk a few moments ago. That's made significant improvement, not only in terms of the overall maximum number of TPS we can achieve, but also in reducing the amount of hardware you need, your ongoing cost and maintenance costs to maintain that level of performance. We need some help, as always. If you have experience, knowledge, or care about the performance of the Moduloop platform in any way, if you're an adopter or an SI, you're interested in understanding how Moduloop performance works, which factors affect the throughput and the latency you can achieve in the system, please come and join the work stream. There's no formal commitment required to join any of these work streams, really. All of our work stream meetings are open, so anyone in the community can join at any time. Feel free to catch up on what's been happening by reading the notes. We'd love to see you on the Zoom calls. They happen every week. You're free to come and say your piece, bring your questions. We'd love to hear from you. Okay, so I think this is the final work stream I'm talking about today. This is a very important work stream, the evolution of Moduloop. So the purpose of this work stream is to think about and plan for the continuous improvement of the Moduloop platform into the future. So every single aspect of Moduloop falls into the remit of this work stream. We meet weekly and we think about how to improve the Moduloop code base long-term into the future. So we look for tactical wins. What can we do now to reduce cost footprint, to improve performance, to improve maintainability, the NFRs and the feature set of Moduloop. But we also think at long-term strategic level about architectural evolution. Right now, we have event-driven microservices, but software technology moves very fast. There are always new ideas, new patterns coming to the forefront. So we try to keep an eye on what's going on in the wider world and see how it applies to Moduloop. In this PI, our number one most important objective has been to further the integration of the Tiger Beetle transaction database to replace our MySQL-based core ledger. Lewis from Tiger Beetle is here today. I'm going to hand over to him in a minute to dazzle you again with one of the fantastic Tiger Beetle presentations. We've also been spending some time thinking about audit trail. We had some feedback from an adoption project that the way our audit trail works can be quite expensive to run in a very, very high throughput system. So we've been doing some thinking about how we can streamline that to reduce the cost footprint. Work is still in progress. This work stream is another one like performance. It's ongoing, it's continuous, it's never going to end. So, without further ado, I'll hand over to Lewis Daly. Tiger Beetle are great friends to the Moduloop community. We've known them since their inception many years ago. Tiger Beetle was sparked from a conversation that happened at a Moduloop convening in Johannesburg 6 years ago. But I say it many times, I would like to really extend very grateful thanks from the entire Moduloop community to Tiger Beetle, Joran, the entire team there, Lewis especially, who's been focusing his time and efforts on integrating Tiger Beetle with Moduloop. I think we're just about to get Lewis plugged in. So when you're ready, Lewis, please come and join the stage.
All right, thank you very much, James. Let me just get all sorted up here. Great to see those performance numbers as well. It's very exciting. Where's the audio gone? So video is this side. Oh, there it is. Reversed. And then sound is on the left-hand side. Great. Yeah, lovely to be here in Nairobi with you all. So thank you for your time and attention. I'm just going to be sharing, like James said, just a few little updates on what we've been working on in terms of the Tiger Beetle integration. Cool, we've got that here. Lovely. So what is Tiger Beetle? For those not initiated, Tiger Beetle is a transaction processing database for workloads exactly like Moduloop, where the most critical things are both safety, we can never lose transactions, and performance. We want to get a lot of transactions through as quickly as possible. The goal, as James said, for the evolution workstream is to get Tiger Beetle into the Moduloop switch to speed up the clearing of payments and also be able to handle more, so both latency and throughput. So switching the switch. What does the switch of the switch look like? If we zoom out at a very high level of what Moduloop looks like, at least a subset of it, we have these three layers here. We have messaging, we have services, and we have state. Messaging being the APIs, services being, this is just three of the microservices that James was talking about, and then our state, which is our message bus, Kafka, and the general purpose database, which currently is used to power the transaction processing of the database. And now, the after, when we're finished with the integration, this is what it will hopefully look like. We're going to essentially take one small piece of what sits in the general purpose database, the transfers table, and a couple other things, and instead of writing that to the general purpose database, we write it to Tiger Beetle. Tiger Beetle is optimized for very fast writes on contentious workloads. So for example, in Moduloop, the position, keeping track of the positions of all the DFSPs within the switch is very contended. And when we send it to Tiger Beetle, we get a pretty decent performance improvement. Additionally, Tiger Beetle's native language is accounting. So for those of us lucky enough to be in Michael's presentation yesterday, translating the new accounting model that Michael and the team have been working on into Tiger Beetle becomes very easy to do. It speaks accounts, transfers, debits, and credits. And then in terms of just a couple little relevant updates on the Tiger Beetle side, we recently had our Jepsen report published. So Jepsen is a framework and also a company for testing distributed systems. It puts them through the harshest of environments and checks to make sure that they don't lose data. So we engaged with Kyle from Jepsen to put Tiger Beetle through the ringer, and we're quite happy with the results. We found a couple bugs which have been fixed, and you can read the report at tigerbeetle.com. Additionally, we've also released our change data capture capabilities. Change data capture is a method where we can stream the changes that come out of Tiger Beetle in almost real time, and then put them into another database. So when a transfer is created in Tiger Beetle, we can emit an event to a message bus and then use that to write to an analytics database, or even back to that first general purpose database that we saw. And finally, we shipped a bunch of performance improvements, bringing up our transfers per second to over 500,000 on commodity hardware, as well as a maximum latency of 100 milliseconds. So we brought down those maximum latencies. So where are we at with the integration? Our goal for the first step of the Tiger Beetle integration is to reach API parity. So in Moduloop, we have 3 APIs that we need to be able to support that will go all the way through into the transfer layer. It's the FSP IOP API, the admin API, and settlements as well. The goal is to bring in Tiger Beetle without bringing in any breaking changes, or to minimize the number of breaking changes. So we can then be able to deploy development environments, get kind of integrators testing this without having to do too much work, without having to update all the other integrations around Moduloop itself. And what we also want to do is release a version with something we're calling the lockstep ledger. The lockstep ledger is an abstraction over the existing ledger, as well as a new ledger, the Tiger Beetle-based ledger. And they run alongside each other in lockstep. So when a transfer comes in, we're writing to both MySQL and Tiger Beetle at the same time, and we can use this to check that the state remains consistent between the 2 ledgers. We haven't broken anything. Additionally, we've invested in a new type of test. So we've got existing tests, as Sam covered earlier in Moduloop, around the golden path test. We've got unit tests, integration tests, all sorts of tests. And we've brought in a new test called deterministic simulation testing. The way that this works, this is an approach we also use internally at Tiger Beetle. We've adapted it for Moduloop. What we do is we simulate the interactions of multiple DFSPs as well as a hub operator around the Moduloop switch using those 3 APIs that I talked about, and ensure that the way that the switch responds is consistent with what we expect. So we're essentially taking a random walk every time we run the simulation test around the state space of Moduloop, and we assert at the end of the test, or actually at each step, we assert that the state of the Moduloop switch matches the expected state, as well as the messages that were exchanged between the DFSPs, the hub operator, and so on, matches the expected messages. And so that's kind of where we're up to. In terms of the API support, I'm just going to walk through very quickly. The admin API, we're up to the point of being able to do everything that is required to onboard a DFSP. With respect to the FSP IOP API, we have the happy path transfer scenarios implemented and not the unhappy path transfer scenarios. So we're up to the point of FSP IOP v1.1. So that is kind of one version behind. And then once we finish this, we'll be able to get onto the FX side of things, but we also need to spend a bit more time on the accounting model. And then finally, a settlement API. There's a lot of work being done around that, but we haven't actually, I can't give that a full tick yet, but we're getting there with regards to settlements. So like I said, this is a show and tell. So I've done the telling, and now we want to do a little bit of showing, if that's okay with you. And actually, I should just test that the sound works. Have you guys got the sound there? Okay, there we go. All right. So Now what we have here is our performance visualization tool called Racer. Now we could talk about the numbers, performance improvements that we see when we bring in Tiger Beetle and whatnot. But sometimes it's more fun to watch something, watch a race instead of looking directly at numbers on a chart. So Racer is something that we built at Tiger Beetle to help us see these two systems. And what we can do is race two systems side by side. And today we're actually going to have two races. So we did a preview of this in Ghana. And I'm going to show you a race between integration we did from 6 months ago and the improvement we've made as well. So who's ready to have a race? Yeah, okay, let's do it. Let's do it. So we have a few tracks here available. Let's start with Super Circuit. Very simple. And we can pick our two races. So the racer on the left, let's pick Mojo Loop on MySQL. And the racer on the right is Mojo Loop running on Tiger Beetle. And just to quickly explain how we've done this, what we do is we deployed Mojo Loop with a specific set of hardware, and then we run a benchmark. The benchmark sends a bunch of transfers through from one DFSP to the switch to another DFSP, and then all the way back again. That's considered one transfer. We send as many as we can, as many as the switch can handle per second, and that gives us our transfers per second. And then we count how long it takes for each transfer to take place, and that's our latency. And the two very important numbers there. Now, what we do is we generate a trace file from this benchmark, which captures at about every second how many transfers managed to make it through the switch and how long they took. Critically, the maximum latency, so the P100 latency, which means like if I'm paying James over a counter for, I don't know, some chips, how long the worst case scenario would be for me to pay him, how long I would be awkwardly standing there waiting for that payment to go through. Okay, let's go. So we have Mojo Loop running on MySQL on the left, Mojo Loop running on Tiger Beetle on the right. Now this is not the latest performance stuff that James presented. So the numbers are just specific to a certain environment, and there is a lot more work to be done. But we want to set a baseline. So given the same set of hardware, when all we do is switch out MySQL for Tiger Beetle, what do we have? All right, let's go. So we're just going to start with MySQL. I think we can give Tiger Beetle a bit of a head start. And you can see that, MySQL's made a bit of a start. We can see down the bottom here on the right, on the left, sorry, we have the trace file that's being read and powers the racer as we go around the course. Here in the middle, we have transactions per second, moving up and down. So this race is around about 100 transactions per second. So this is given that set of hardware, like I said. And then our maximum latency. So the maximum time we're going to be waiting for a full end-to-end payment to clear. Do you think we've given MySQL too much of a head start, or do you think Tiger Beetle can catch up? What do you reckon? Should we wait a bit longer, or should we go? Okay. All right. Ready, set, go. And once again, a little bit of a slower start, but here we go. Tiger Beetle has now overlapped the MySQL integration. But have a look here as well at the latency. The latency is still too high. So this is the work that we did all the way in April, so 6 months ago. And we're going to have another race in a second, once this race is over. And we'll see how we go. Okay, there we go. Quick little replay. Okay. So, while these guys finish the race, let me set up the second race for you guys. Now, what we're going to now do is race the April integration of Tiger Beetle with the October integration of Tiger Beetle. So I did some benchmarking last week. This is once again on a very similar set of hardware. Actually, it's even penalized a little bit more. And what I really wanted to do was focus on that latency number, because the maximum latency of, what was it, 8 seconds to do a payment is simply too high. We want to get that under 1 second, and we'll see. We haven't quite made it, but we'll see the progress that we've made. So let's pick a different track this time. Mount Boom. All right. So we've got Mojaloop and Tiger Beetle April. So that was our racer on the right-hand side. Now he's on the left-hand side. And then Mojaloop and Tiger Beetle in October. So benchmark from last week. Now what we're going to also do is give a head start of just 1 second to Tiger Beetle from April. And you'll see why in a second. All right, are you ready to go? Let's see how the performance is improved. Yep. Set. And go. So both of our races are on the course now. We're still seeing around similar TPS numbers. And I should note, the Mojaloop on Tiger Beetle running October has actually got a penalty because the Mojaloop on Tiger Beetle was running with a single node Kafka, and now Mojaloop in October is running on triple node Kafka with F-Syncs running with every batch of payments. So it's actually been penalized, and by improving a bunch of the stuff in terms of Kafka processing, notification handlers, we've brought down that maximum latency. And there we go. So we can let them have the replay, but basically that's the work. That's what we're up to. You know, there's still a lot of stuff that we're working on. Still a lot of performance to be had. But yeah, we're getting there. I don't know what else there is to say. James, I'll hand back to you.
Thank you, Lewis. You can see why we're so excited about this piece. I think it was finished anyway. As with all the other work streams I've talked about today, please do come and join in. Those calls are open. You don't have to say anything if you don't want to, but please come and join in, have a listen, see what kind of work goes on. Maybe if you feel like speaking your mind, share your opinion with us, we'd love to hear what you want to think. Mojaloop is driven by our community. You guys are in the driving seat. Please come and tell us which way you want to go. Okay, thank you very much, everybody. I'll hand back to Simeon.